Hello, I'm Dr. Miller. I'm here to present to you a better way to teach math. With all the knowledge and skill, why do we have difficulty transferring understanding of math? We teach through rote, practice, and tests for following the rules. Furthermore, we teach some things incorrectly. What we should be doing is leading the student to discovery, organization, good retention, speed and accuracy, easiest way to solve problems, and challenging the teacher. Watch a good student solving a puzzle and what he does to master the solution. To teach math better, we have to look at the student, teacher, and parent and understand and apply the best teaching practices. How we implement these practices is what determines success or failure. Good students study differently than they are taught. Feedback between student and teacher opens the doors to achieving our intentions.
It would be difficult and time-consuming to go through each and every lesson in math that has to be changed according to the new plan. So what I'm going to do is take one particular subject, multiplication, and try to illustrate quickly how this approach works. So let's begin with learning the multiplication facts. What we do is we set the thing up in terms of learning patterns that numbers create. So for example, with the nines, we find that if we subtract 1 from the number and take the tens complement of the number, we get the answer. So 9 times 3, 1 less than 3 is 2, the tens complement is 7, 27. Even kindergarten kids can learn this way. Then we observe that adding 0 and 1 are fairly easy, so we don't have to spend much time on that. Learning to multiply by 2s turns out to be a little bit more difficult than one would expect because children have trouble adding numbers. And so what we've done is we've taken this and built upon the addition. And once they've done that, we can double again, and that already brings in the fours. So the doubling process brings all those numbers in red. And it turns out that 5 is a special number because it's halfway between. And as a result, when we multiply even numbers by 5, we take a half and put a 0 after it. When we multiply even numbers by 6, we take half of the leading digit, like we did with the 5s, and then put the number afterwards, making use of the distributive property. And so as you see, using these particular rules, we only are left with 6 that we actually have to memorize. And so as a result of this, children can learn math in first and second grade fairly easy because of the fact that it gives them a backup scheme when they can't remember what they're doing. So we don't rely on intention. And what we try to do is lead the students to discover these rules for themselves. So the rule for fours, which I talked about, which I call double trouble, was taught to me by one of my students. Now we look at long multiplication, and all the ramifications come from that. Suppose we wanted to multiply a number by itself 100 times, in which there are applications in high-level math which we would possibly want to do this. Nobody in their right mind would do that. So what we found is we found an easier way of getting it, or a faster way, students could try it. And so what we've discovered by making use of the rules of exponents and the base 2, that we can do this in 8 multiplications. And this is illustrated with these multiplications that we've done here. So 8, not 100 multiplications. Also, the student learns the value of round off, learns something about errors, and learns a way to get the problem easily. And what we do is we lead the student to making these discoveries since we know what the final goal is. Ownership gives possession. Now, normally, most students can't do beyond 5 by 5, 3 by 3 multiplication. They make up the rules because they never learn to understand it. And if there are shortcuts, they don't take the shortcuts. So for example, doing this multiplication over here on the right, the student puts all these rows of zeros, fails to recognize that they've multiplied by 5 and don't have to do it again. And so they get this long process. If they understood the distributive process, they could just multiply by the 50, which would give us this answer here, and then multiply by 50,000, And we learned that we put the starting digit under the number, and this is the results with all of that extra mess. Now, what happens if we want to do something more complicated? And this was really something in terms of leading the student into something. Taking the squared is something we don't spend too much time on. But it turns out that the check and guess method, which is often mentioned, is too cumbersome to take, particularly as we get to longer digits. So what we've done is we said, can we make use of what we've done before? And I illustrate this here by if we knew how to multiply by 1, 2, 3, 4, 5, which we did in the previous slide, to multiply by 1, 2, 3, 4, 5, 6, we don't have to go through 6 rows of 6-digit each. We can copy the result we did from 1, 2, 3, 4, 5 squared, add a couple zeros, then just multiply 6 times this number, and then copy it because we're multiplying it 6 again, and then multiply 6 times itself. 4 steps, easy steps. And so what happens is after we've done a check and guess on the first digits, we can actually make use of the results from the first process into the next digit. And you'll notice this all along the way. And so as a result of this, we don't have to do a lot of multiplications, and we're just doing a few extra digits as we move place to place. And so as a result, we've now made a product manageable. And in doing this, makes math more interesting, and the fact is there are tricks, and what we do is we encourage the student to find those tricks. Now, this was one which I have had first grade students do after they've learned their multiplication, and that is, suppose you had to multiply 1, 2, 3, 4, 5, 6, repeat it 3 times and square that. This is the steps that we do making use of the distributive property. We already know how to multiply these two from this operation here. And so as we repeat this using the distributive property, we just copy these lines down. Once we've added this, we copy the line down, moving it according to the number placement. And this is the answer. How effective is this? Altogether, doing all this, it's 150 digits. If we did it the traditional way, it would be 324 digits, and it would be almost impossible to get the right answer. So illustrating with multiplication, which is just a small part of the problem, we've shown that by using the techniques I've described, which are well known in mathematics, but implementing them properly, that we can teach children far better than we've ever seen before. This includes learning challenged children and gifted children. Of course, the children in the middle are going to be significantly improved also. So let me summarize. We talked about asking questions, discovering how somebody discovered this before. Basically, I was showing the children my discovery process, finding patterns so that we don't have to memorize, organizing the work. That's what was key in those multiplication problems. The easiest way to solve a problem. Most often we'd use the most difficult way. Check for errors. This is really key because it gives you more interest in the answer. Most children don't seem to care about whether they get the right answer or not. Describe your work. Use programming languages to be able to have the kids write a program, and then so they're describing what they've done. Understanding postulates and proving rules. This has been a big part of the feature that we have. And we go for speed. This enables the child to test themselves. And as a result of this, they can be self-teaching, which is what the goal is that every school puts in their motto. So the challenge is much easier than one realizes because I've tried and tested this with many students. Let this be the umbrella for your approach to teaching. Thank you for listening to the presentation, and hopefully you can make use of this, that you will look into using this program.